In this lesson, we're going to learn how to graph quadratics. So, just want to remind you of some of the key points that make up a quadratic, which when you graph it is known as a parabola. All parabolas have a vertex, which is either the minimum or the maximum height that parabola will reach. The points at which it crosses the x-axis are known as your x-intercepts or your roots or your solutions, and that's where we spend so much time doing the ZPP or the quadratic formula to find out what those values are. Parabolas are symmetrical. This line that cuts right through this vertex is known as the axis of symmetry. Remember that it's always in the form of x equals some number, and that number would be the x value of the vertex. The point at which it crosses the y-axis is known as your y-intercept. One other thing I would remind you of is, remember, if there's no x-intercepts visible, that it doesn't cross the x-axis, it's because your roots are imaginary. In our last unit, we spent a lot of time looking at the different forms. Remember that standard form looks like this. Here's vertex form, and if you remember, vertex form tells you the vertex, the h and the k value. Remember I always said opposite same? So your vertex here would be h comma k. It's the opposite of the value you see in parentheses and the same as the k value. And the third form is intercept form. It's when it's already factored. Okay, another thing I want to remind you of is what the a value does regardless of what form it's in. So they all start with this a out front. Remember that if a is positive, so if a is 2, your parabola opens upward. So another way of me saying that is positive. We got a happy dude here. Where if a is negative, if it's like -2, if you're negative Nancy, your parabola frowns. Okay, it opens upside down, so it's unhappy. So I just want to remind you of some of the properties of a parabola. If I pick an x value and I plug it into my function, like -3, and I square that, I get +9. If I plug in -2, square it, I get 4, whereas -1 squared is +1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. And I go over here and I graph this. Look at what I notice first of all. I've got this symmetry happening. Do you see how the y values are the same? So because my vertex is 0, 0, then I have 1, 1, -1, 1, 2, 4, -2, +4, 3, 9, and -3, +9. And there's that parabola we know it needs to create. And notice the symmetry, even though my sloppy handwriting makes this a little tougher to see, about that axis of symmetry. The y values, look at this, are 2 units away from the axis of symmetry. Here it's 3 units away from the axis of symmetry. Down here, 1 unit away from the axis of symmetry. So it always maintains a symmetric shape, which we can use to our advantage as we go to graph. If we really just find our vertex, and then we're going to be using GMM to do our graphing, we're only going to really need 2 points because GMM is going to establish the symmetry for us. Okay, so let's graph this one in vertex form. First thing that jumps out at me is that my a value is negative, so I know my parabola is going to open downward, and I'm going to find the vertex to start. So if you remember, your vertex is -b over 2a, and then you're going to plug in to get the y value. All right, so -b would be -100 over 2 times -10. If you remember, here's your A, your B, and your C, in case you forgot that, is -100 over -20, which is +5. So in my table, I'm going to put 5, and how do I get my y value? Well, I'm just going to plug in. So plugging into my calculator produces a y value of 6. Okay, and then, so there's my vertex. I'm going to go 1 value to the right of that vertex, so 1 bigger than 5 would be 6. I could go 1 smaller, be 4. And when I plug in 6 into my function, I get -4. If I had plugged in 4, I would also get -4. So notice the symmetry about the vertex, but beautiful thing, when you switch to GMM, you only need the vertex and one other point, so let me show you how to do that. So to graph this in Get More Math, I am going to switch my tool to say Parabola since it's quadratic. First point you always have to graph is your vertex. So we found that to be 5, 6. So right 5 and up 6, and I put my first point. And all you need is one other point on the curve in Get More Math, and it will use symmetry to draw the rest for you. So it's kind of nice. So I'm going to go to that second point to the right, which was 6, -4. So I go right 6, down 4, and I put my second point, and it automatically draws in a perfectly symmetrical curve. So you can see that axis of symmetry there, but that's all you got to do. So I hit this, and I get the happy smiley faces. Okay, let's graph this one in vertex form. And I do want to point out in the last slide I called it vertex form when it was standard form. It was typed right, but I said it wrong. Okay, this one is vertex form. It goes in parentheses is your h and outside is your k value. So I always told you opposite same for the vertex. Now, I'm going to identify it first. It would be in this scenario +4, -1 would be my vertex. Now I need one value to the left or to the right. So I'm going to go +5, and all I need to do is plug that into my function. So I have y equals 5 minus 4 quantity squared minus 1, and that produces 0. So I also know that 1 to the left would be 3, 0 as well. So let me show you how to do this now in GMM. This parabola on Get More Math, again, change to the parabola tool. The vertex, opposite same, is +4, -1. You gotta plot your vertex first. And one other point on that curve is 5, 0, right here. So there, by symmetry, it draws in everything else. Check. Yay. Okay, so we're going to graph this one. It's also in standard form, but I said it's kind of ugly because look at those fractions. But big picture again is we just need our vertex, which again is -b over 2a, which in this scenario is b is +5, so I make it negative. So -5 over 2 times 1/2 is -5 over 1, which equals -5. So in my xy table, I put my vertex here in the middle would be -5, and I'm going to plug in to get my y value. So take a second, pause the video, and plug that into your calculator. So when I do that, I get +2. And I'm going to need at least one more point to the right. So 1 to the right would be -4. Go ahead and type that in your calculator. I do, and I get 2.5. I know I might have a little bit of a hard time doing a decimal value, so if I go one more to the right, like -3, that would be +4. Now, again, just to point out, if I had done symmetry and I'd gone to the left of these, so notice I go -6, -5, -4, -3. Using symmetry, this one would have to be 2.5, and this one would have to be 4. Okay, so let me show you in GMM how to graph this. So as I go to graph this one in GMM, again, I'm going to switch my tool to say Parabola. You got to plot your vertex first, which is -5, 2. So that's right here. And then I need one more point on the parabola, so I just kind of hold down my cursor, and I'm going to plot the point -3, 4, since that is going to be easier. -3, 4. If I just click here, it draws in the rest of the parabola for me. Hit enter, and it's happy. Okay, so this final form, intercept form, is not available to practice and Get More Math, but I want to show it to you because I have a Schoology question that you need to answer. So for this one, the intercepts, if you remember, love this, are your roots. So they would be -4 and +2. So if I go on the x-axis, crosses at 2 and -4. And I know my parabola is going to open upward, so really the only other thing I need here is my vertex. And if you remember the vertex using symmetry, well, it's got to be halfway between those two. So the easy way to get it is just, well, halfway between those two values would be add them together and then cut it in half, divide by 2. So -4 plus 2 is -2, divided by 2 is -1. So I know that the x-coordinate of my vertex is -1. And the y-coordinate, well, all I have to do is plug it back into my original function. So when I plug it in, I get -18, which is, of course, way off my graph. It's going to be down there somewhere. So this is not the best sketch, but it's going to be way down there at -1, -18. The final thing I want to point out is in these, if we were doing this in class, I would be showing you on your graphing calculators how to do this. And since you don't have a graphing calculator at home, one of the great websites for graphing on your computers is desmos.com. If you just type in the function, it draws the beautiful parabola for you and you can see all the points you need. But you do have to know how to find your vertex and at least one other point to do a good sketch. Okay. Also, if you are trying to download something for your phone, Android Wabbit Emu is a great one. It looks identical to the ones we use in class. If you have Apple products, Calculate 84 is a decent calculator for you. Okay, reach out if you guys have any questions. Let's do this.